All right, so we need to start off our pre-calc class with a review from a few years ago, actually. Little coordinate geometry is what we're going to discuss today, starting with the distance formula. So odds are that you, somewhere in the back of your brain, have the distance formula memorized. If you do, that's awesome. Oops, let me get rid of my messages. And the distance formula is a derivation of Pythagorean theorem because the distance between 2 points is the hypotenuse. If you create a right triangle, we'll derive that in a moment. But it is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now that's kind of like a lot to say, even in my brain. I never say it that way. What I do is I say it's the square root of the horizontal squared plus the vertical distance squared. I mean, that's what I do, but you know, do what you want to do. So let's look at an example. If I just make up 2 points, like for instance, -3, -4, and let's go with 4, 5. So if I plot those 2 points, -3, -4 is located right there. And then 4, 1, 2, 3, 4, 1, 2, 3, 4, 5 is up here. If I want to find the distance between these 2 points, what I would think about if I'm trying to derive the formula is creating a right triangle. Because if there's one thing that every kid remembers from geometry, it's Pythagorean theorem. And then the hypotenuse of that right triangle is going to be the distance between those 2 points. So the horizontal distance from -3 over here to the x-coordinate of 4, that is 7 units long. It doesn't matter if you do the math and it comes out to 7 or -7 because you're going to square it. And then the vertical distance, this down here was -4 in the y direction, and up here this was 5. So that was a distance of, whoopsies, I kind of missed the boat there, 9 units. Again, positive, negative, doesn't matter, because when you go to use the formula here, you have the square root of 7 squared plus 9 squared. Oh gosh, I should have made up an easier one, huh? All right, let's see, that's 49 plus 81. I don't have a calculator with me right now, so that's the square root of 130, which actually is a great answer. That's the exact answer. If it was a radical that you could reduce, I expect pre-calc to reduce that properly. 130 does not reduce, though. The decimal equivalent to that is, oh goodness, let's see, 11 point something. I'm not sure what it is off the top of my head, but you would round to the nearest tenth generally if they wanted an estimated answer. It kind of depends on the nature of the question. So keep that in mind. Distance formula, you must have it memorized when we take our first summative. I'm going to ask you to give me distance formula. So here, find the distance between each pair of points, and then here it does say round to the nearest tenth place. So what I'm going to do is I'm going to kind of cheat my way through this question, and I'm going to look at the horizontal components, which is 4 and -8, and those are 12 units apart. So I'm going to say that's 12 squared plus, and then same thing for the vertical components. I have 3 to 6, that is 3 units apart. I'm going to compute the math here, come up with the square root of 144 plus 9, which is 153. And since it said round to the nearest tenth, we're going to say this is approximately 12.4. But just be forewarned that, you know, at some point in your future, math teachers or SAT tests might expect you to give the exact answer there. Square root of 153, excuse me, does reduce. It is the square root of 9 times the square root of 17. So the exact answer would be 3 squared of 17. Since the directions did say round to the nearest tenth, we're going to go with that. All right, same thing here on number 3. You're just going to find the distance between the 2 points. So for the sake of everyone's time, I'm just going to skip that one. Midpoint. Midpoint, you should know the formula. Again, you're going to be asked to know the formula on your first summative. The midpoint is a point in its own right, so it is an ordered pair. And it's just the average of the x's and the average of the y's. So if you think about how you average things, you would add the 2 points together and then divide by 2. And you're going to do the same thing with the vertical components. So y1 plus y2 divided by 2. That's how we're going to calculate the midpoint. So I'm going to come up with, it doesn't really matter what I come up with, but it's just some example. How about we use the same one as before, -3, -4. Is that what I used? I already forgot. Oops, -3, hello. -3, -4, and 4, 5. Okay. And 4, 5. Okay, so again, we're plotting 1, 2, 3, 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4, 5. The midpoint is, you can kind of estimate it visually of it being like roughly right here, but you actually have to calculate it for us here in PreCalc. So since we know our formula, we're going to be doing this formula with these ordered pairs. So here's your x1, here's your x2. If I were to add those together, that would be -3 plus 4 cut in half. And then same thing with the y1 and the y2. That would be, let's see, -4 plus 5 cut in half. Now, sometimes we get calculator happy, which is, great if you're in a stressful moment, but you guys know what -3 plus 4 is. That is a 1 divided by 2, so this is 1/2, comma, also 1/2. If you want decimals, that's fine, 0.5, comma, 0.5. So right here is the location of the midpoint, and I can kind of visualize that to be accurate. So I really like coordinate geometry questions just in general, because I think if you're in a jam, you can kind of figure them out, even if you forgot the formula. But again, to reiterate, you do have to know the formula. So here, the midpoint between these two ordered pairs is going to be the average of the x's, so 8 plus the -4 divided by 2, and then same thing with the y's. So let's see, well, it doesn't matter which one you do first or second because we're just adding. So -3 plus 3 divided by 2. All right, simplifying that would be a 4/2, which is 2, and then 0/2 is 0. Very good. Again, you must know formula for your test. We call summatives. Them summatives in PreCalc. All right, notes on slope. You have probably 5 different definitions for slope, but the formula that you need to remember for slope is y2 minus y1 over x2 minus x1. You can reverse the order on that, as long as you maintain that order through both x and y. Generally speaking, this is the one that math teachers try to beat into your brain, so maybe try that one if you're just memorizing for the sake of memorizing. The general rule for slope that we try to remind kids of what slope is when they're having a tough time, we might tell a child, oh, it's the change in y over the change in x, or we might say something like rise over run. And these are all accurate, but when it comes to giving me a formula, I'm going to be expecting you to give me one of these two formulas here. And you might be asking yourself, why M? Why is M slope? I don't really have an answer for you, because actually other countries don't use M for slope. So whatever. You can go America. All right, so that same ordered pair set that we had before, -3, -4, and 4, 5. 1, 2, 3, 1, 2, 3, 4. All right. 1, 2, 3, 4, 1, 2, 3, 4, 5. I should have just figured that out. All right, so yeah, it is rise over run. So if I'm trying to do this visually, I'm trying to figure out how far did this ordered pair rise from here to here, and it went up. Remember the y value down here was, what was it, -4, and then up here it was a 5. So it went up 9 units. And then it went over to the right 7 units, because remember this was -3 and this was a 4. So something to remember from your algebra life, that if you travel upwards, it's positive. If you travel to the right, that's a positive movement. If you travel to the left, that's negative. If you travel down, that's negative. So the other thing that I like to do at the end of my question is, if I visualize the slope going from here to here, that is a positive slope. I can kind of tell that from my experience with graphing lines. So I want to make sure whenever I do this, it comes out positive. All right, so finishing this up here, we do need to calculate our slope. I would like these slope ratios written as improper fractions, reduced of course. So we traveled up 9 and right 7, so +9 over +7 means we have a slope of 9 over 7. Decimals are technically okay for the normal world, but in math classes they always want answers a certain way. So here we're finding the slope between these 2 points. I'm a stickler for y2 minus y1, so I always go in that order. So I take y2 and subtract y1. My dyslexia allows me to make really silly mistakes, So I have to kind of stick with the same order every time so I don't do anything weird. And then this will be x2, and this is x1. So let's see what we have here. -4, careful with the negatives, minus a -16. Sometimes the subtracting negatives is what messes with kids, so make sure that if you're typing on your calculator, you're calculating these separately. 8 minus 13 is -5, and then -4 minus -16 would be -4 plus 16, so that would be a 12. So our slope is reduced ratio of -5/12. All right, again, I'm going to skip the next example because I'm bored. All right, so now we're on the back of worksheet 1, and we are graphing some lines. So our first few lines are in what we call slope-intercept form, which you do have to know for your test. Some people call this the quick graphing form because it's very easy to graph when it's in slope-intercept. Slope-intercept form is y equals mx plus b. It's called slope-intercept because you can identify the slope as the coefficient to x, and the y-intercept is this value b off to the side. So you start by plotting a point at on the y-axis at wherever the b is. So plus b, in this case it's plus nothing, so we're going to start at 0 on the y-axis. And then your slope is your rate of change. It tells you how to move. So for this example, the slope is 4, but remember slope is always a ratio of rise over run. So 4/1. Traveling up 4 units, 1, 2, 3, 4, and over 1 unit to the right, that is +4. Could also move down and left because negative over negative would also be positive. Now unfortunately I'm graphing on my tablet, so this doesn't usually work out very well. I almost made a line. Alright, pretend that's a line. Make sure there's arrows on each end of your line. Alright, so here we have a y-intercept of 3. So on the y-axis, start at 3 units up. And then your rate of change in this example is -3/2. So the negative either goes with the 3 unit, the rise, or it can go with the run, but not both at the same time because 2 negatives would make a positive. So watch what you do here. So I'm going to travel, I always make my vertical rise negative if the slope is negative. So down 1, 2, 3, and then to the right +2. Could have moved up 1, 2, 3, left 2. Either way we get this negative sloped line. Oh man, that was really bad. There we go, that's better. Alrighty, you'll learn to love my terrible drawings after a while, right? I'll keep telling myself that. Alrighty, moving along. Let's graph some other ones here. X equals 2, that is a specialty line. It's one of the lines that are from one of the axes. It's not a diagonal line like you're used to. This one is going to be a vertical line. So the way I remember it is x equals 2. I go to where x equals 2 on the x-axis, of course, so right here, and I draw a line straight through that point. So x equals 2 has no restriction or any sort of information on the y. That's why you see it goes forever in the y direction, and we have a vertical line. By the way, vertical lines have undefined slope. In case you're ever quizzed on that, keep that in mind. All right, so here, this line is not in that quick graphing form, so you can either rearrange it so it is in the quick graphing form, or I'll show you another technique. So you could isolate and rearrange so it's in y equals form. So first thing you'd do is you'd subtract the x over. So I still have 2y equals, I'm going to write it as -x plus 6 to keep the x in the first part of the equation there. And then divide by 2 everywhere. And now I see that the line in slope-intercept form is, this is a -1/2 x plus 3 when you reduce. So I'm going to be graphing that line. The other way to graph would have been to find the X and Y intercepts. And I actually really like graphing it that way. I just find it quicker, but you do what you want to do. We're flexible here in math. All right, so the x-intercept would be where your y value is 0, and the y-intercept would be when your x value is 0. So the way I calculate that is I go back to my original, this is called standard form, by the way. And I go and I basically cover up the term that has a 0 plugged in, if you will. So for the x-intercept, if y is 0, 2 times 0, this whole term here would knock out, and you get x equals 6. So that was easy, huh? Okay, now for the y-intercept, when you substitute in a 0 for the x term, this term would knock out, and you get 2y equals 6. So then if you do a little solving there, you find out that y is 3, because you're going to divide both sides by 2. So either way, you end up with the same line. So if you graph the ordered pair 6, 0 and 0, 3, and you graph that line, that's the same line as negative 1/2 x plus 3, because you would have started at plus 3 and then moved down 1, right 2, down 1, right 2. So totally up to you what method you choose for graphing. The important thing is that we are going to be graphing accurately in this section. So y equals negative 3, that's one of those specialty lines again. There is no x component there, so there's not going to be a slope. So y equals negative 3. On the y-axis, I go down to negative 3 and I draw a line through it, and we, ooh, hello, we end up with a horizontal line. And just for fun, I need you to remember that horizontal lines have slope equaling 0. Remember the words I just said where it's going to have no slope. So there is no change in y over change in x. There's no rise over run. All right, so here we have that standard form again. You have to either isolate or find the x and y intercepts. Totally up to you. So if you choose the isolation method, you would start by subtracting the x, but be careful, there's still a negative y in front of that. So negative y equals negative x minus 3, and then hitting everything by a negative 1 or dividing everything by a negative 1 does the same thing. You end up with y equals positive x and a plus 3. If you chose to find the x and y intercepts instead, I'll go ahead and practice that with you real quick. So the x-intercept is where you plug in a 0 for the y, and the y-intercept is where you plug in a 0 for the x. And I go back up to the original problem here. X-intercept would be nothing right here, and you get x equals negative 3. And then the y-intercept would be nothing here for the x. Negative y equals negative 3, dividing by negative 1 on both sides gives you y equals positive 3. Again, it doesn't matter because you're going to end up with the same same equation, same line. Oh man, unfortunately, if you can't graph, you got problems like me. Alrighty, let's pretend that actually looked good. Sometimes I get on a roll, but you know what? I haven't done much work this summer, so I'm a little rusty. Oh man, you have a worksheet coming up for homework here where you have to remember how to solve this. So what I need us to do is to remember what's called the LCD or the Lcm method. When you have fraction coefficients in an equation and you're being asked to solve it, no one likes fractions, not even your math teacher. I mean, sometimes they do, but not generally. So what we have to remember is in this method, since it's an equation, I can multiply every single coefficient, every single term by the same common multiple. And I do this in an effort to knock out all the fractions. So I look at all my denominators, and I try to find the least common multiple of all of those denominators. So, oh man, this one is going to take me a minute because I don't have a calculator with me. Let me go grab a calculator because that 7 and 8 is messing with me. One moment. Alright, so my search for a calculator was fruitless. I don't have one. However, there's good news. I don't have to find the least common multiple. I just have to find a common multiple. And 40 is 8 times 5, so I'm not worried about that so much. The 7's really messing me up, though. So what I'm going to do is I'm just going to multiply 7 times 40 together. This might not be the least common multiple, but I don't really care. So the common multiple I'm going to use is 280, because 40 times 7 is 280, I think, if I did that right. So here's what you do. You take this 280, which is 280 over 1, and you think about multiplying it into every single term. You're going to distribute it to everybody. Of course, you have a calculator with you at most times in math class, so you could just simply take 280 and multiply it by this fraction and get an answer. But I want you to be able to do this reduction without a calculator if you were like stuck. Oh man, I don't have a calculator either. This is going to be rough. So right here. All right, so apologies. I have to had a technical malfunction. So hopefully this is editing properly, and we left off somewhere at this point in this question where we came up with the LCM of 280 for a 47, 8, and 5. Yuck. Might not be the least common multiple, but it's the one I'm going with. So 280 times this coefficient here, which you could literally just type that on your calculator as 280 times 180 over 40, is 1323. 280 times 2/7 is an 80n. And then 280 times 17 over 8 is 595. And then 280 times 6/5 is 336n. So what we've created is a common multiple question. It's called a linear combination technically, but it's equivalent to the original equation. But since we hit it by this common multiple, we no longer have rational coefficients, and now we have a nice whole number for coefficients. It doesn't really make your work that much better, though, because we still have quite a bit to do here. I'm going to collect these n's together. I know I should be able to add that, but, you know, it's still the summer for me, so I'm a little slow today. This is 416n. And then while we're doing a little work here, I'm going to go ahead and subtract this 595 over. Whoopsies. All right, so again, summer. I don't really feel like, I'll be honest, I wouldn't do this in my head on a good day, much less a summer day. All right, 728 equals 416n, and then dividing both sides by 416. This is the next time a fraction shows up, but you know what, we're done, and I have a calculator, so I don't really care. I feel like I might have messed up something here. I either messed up on this, doing this math here, or I messed up on my slides that I'm attaching to this video, but, you know, whatever. Apologies. All right, move it along. Oh, goodness. All right, this next one, not nearly as ugly as the last one, because as I look through my fractions and I look at my denominators, this is a 1 technically, 1, 4, 3, and 84. The common multiple there is an 84. So I'm going to multiply everything here by an 84, and I do mean everything. Sometimes kids get into the trouble of they just multiply the fraction coefficients. It actually goes to every coefficient, because everything's a fraction if you think about it that way. So my new equation is 84n minus, let's see, that's 105 plus 28, and then equals 199. So again, not the prettiest equation we've ever seen, but it's not too bad. All right, I'm going to combine those together. And new equation is 84n. This is now a minus 77 equals 199. I'm going to add 77 to both sides. Resist the urge to do this without showing lots of work, because, you know, things go wrong. All right, so that's what, 276, right? So, oops, divided by 84. And I need an exact and reduced answer. So if you say this is 276 divided by 84 and that's your answer, that's not reduced, so I'm not going to give you full credit for that. With our grading system, I'd knock you down to a 4, so make sure you reduce it and you give me the exact, because you have a technology piece here that does this for you. If you just hit math enter on your answer, you're going to get the exact and reduced answer. All right. Oh my. I was grumpy when this problem showed up, huh? All right, so you already have fractions and distribution. Let's take care of this initial distribution, and then we'll come back and do the LCM method. So, oh boy, let's see here. I think I already did all this work if I go back and find all my problem set. 23. All right, times, oh my goodness. Okay, so that's 207 over 10 x for this first one. And then this is 391 over 40. Did not do that in my brain. I most definitely used a calculator, so I expect you to do that as well. These last few terms haven't changed yet because we have not distributed anything to them yet. So now when I look at my new equation, my denominators of 10, 40, 8, and 40, a good common multiple to use there, I'm thinking of 40. And that is the least common multiple I could use. So I'm going to go ahead and distribute that to everybody. All right, I should have brushed up on my handwriting before I started our work today. All right, so this first term, when I multiply by the LCM, I get 828x plus, this is going to be a 391, the 40s will cancel. Let's see, that's a 145x. And then here the 40s will cancel again, giving me negative 3707. Again, not a terrible equation, but also not anything I really want to do in my head. So I'm going to combine these like terms. And what do I end up with? I think I already did that. 683x. I'm going to go ahead and subtract this 391 over. Being in pre-calc does give you the option of scrimping a little bit on your work as far as like doing multiple steps in one time. I'm okay with that. Gosh, that's negative 4098. And then this cracks me up every time because we're going to go divide by 683. And you know what we're going to get? A beautiful answer, I believe, of negative 6. So after all that work, x equals negative 6. I would have never predicted it had I not already keyed it. All right. So that is the end of worksheet 1, side A and B, plus a little extra stuff to get you going on your homework. The homework that follows along with these problems starts on, let's see, my goodness, worksheet 3A and B, and I believe we assigned, oh, I don't want to tell you wrong. Looks like we assigned the odds on worksheet 3 and worksheet 4 coming up soon. The next lesson is going to help you remember everything you need to know about worksheet 4.